Hello everyone, welcome back to another Kinetic tutoring episode. Today we're looking at Set 1, Problem 3 of the 2017 AP Physics C Mechanics exam. So let's just get straight into it. We're given this setup, and the prompt is basically explaining the setup, nothing special. So let's just take a look at part A. Calculate the total kinetic energy of the cylinder as it reaches the horizontal table. And as we can see here, the kinetic energy is going to be equal to the potential energy that is transferred. So let's just find the potential energy that we begin with, which is, we know gravitational potential energy is mgh. Our value for m is 0.5 given here. Our g is going to be 10 and our h is going to be, we're not given an h, but we're given a length here and we're given a degree. So we know that this, due to this, just knowing the sine of 30 degrees, is going to be half of the hypotenuse. And since the hypotenuse is 1, this is just going to be 1/2. So we'll get 0.5 times 10 times 0.5. This is 0.25 times 10 is 2.5 joules. There you have it. There's your answer for part A. Calculate the angular velocity of the cylinder around its axis at the moment it reaches the floor. So here we're at a new kinetic energy. So the kinetic energy here is going to be the kinetic energy that we get from this much potential gravitational energy. So we're going to change the height. Instead of it just being 0.5, it's going to be 0.5 plus this additional 0.75. So it's going to be 1.25 times 10 times 0.5. This will give you 1.25 times 5, which is 6.25 joules, but we're asked to give the angular velocity. Alright, so 6.25, that's going to be equal to our kinetic energies, which is 1/2 mv squared plus 1/2 I omega squared. And from here, we're supposed to find the omega. Let me just plug in my computer really quickly so it doesn't run out of battery. Alright, all good. So from here, first thing we want to do is put this in terms of v in order to solve this equation. And we can additionally multiply everything by 2 to make this simpler. So we'll get 12.5 is equal to mv squared plus I. We know that that's just v over r squared. So there we have that. And the inertia, we're given a equation for mr squared over 2. So let's write that out. 12.5 is equal to mv squared plus mr squared over 2. When we write this out, we'll get v squared over r squared. These r squareds will cancel. So we'll get mv squared over 2. So from here we can see that we have 3/2 mv squared is equal to 12.5. So therefore our mv squared is equal to 25/3. And we're given a value for the mass, which is 0.5. So divide by 0.5, our v squared will be 50/3, so our v is going to be square root of 50/3. So now that we got that, I'm going to erase everything we have so far. V is the square root of 50/3. And we know that v is also equal to r omega. So this divided by r will give you omega. The radius is 0.1, so we'll get this times 10, So our omega is going to be 10 root 50 over 3. Or you could otherwise write that as root 5,000 over 3. So there you go. There you have that. Let's find the, it says calculate the rotational kinetic energy to the total kinetic energy. So we actually already did that because the ratio doesn't really ever change unless the ball is rolling while slipping. So, the way we're going to do this, we know that what we found for our rotational kinetic energy is 1/2 mv squared, where our translational was mv squared. So our total will be 3/2 mv squared. And when we divide this by this, we'll get that our rotational kinetic energy is 1/3 of the total kinetic energy. Let's move on to part D, which is asking us to calculate the horizontal distance D. Alright, so we got that V is equal to the square root of 50/3. And from here, we know that it's all going to be horizontal. So we need to find the T it takes for a ball to drop down here. So we know that that's just going to be 5t squared is equal to 0.75. This will give us 0.75 divided by 5 will give you 0.15. So square root of this is the time that it will take. So 0.15 times 50/3 due to our kinematics equations will give you the distance. So the distance that the ball will travel is square root of 0.15 times the square root of 50/3. And the way I did this is by using multiple kinematics equations. This one is 1/2 at squared, the 1/2 at squared kinematic equation, and this one is the velocity times time one. So let's move on to the multiple choice for part E. Is the total kinetic energy of the sphere at the moment it reaches the floor greater than, less than, or equal to the total kinetic energy of the cylinder at the moment it reaches the floor? Alright, so let's think about this a little bit. Okay, so we're given a sphere that has an inertia 2/5 mr squared. And we know that the total kinetic energy is the rotational plus the translational, and these are equal to the potential energy, which is just mass times gravity times height. And as long as all three of those factors are equal, which they are, the total energy will also be the same. So the answer is equal to. So the rotational kinetic energy of the sphere at the moment it reaches the floor greater than, less than, or equal to the kinetic energy, rotational kinetic energy of the cylinder. So due to the fact that the one with the greater inertia is going to be rolling slower, and in this case that's the cylinder, so the cylinder is going to have more energy spent on it rotating and therefore less on it translating. So the cylinder is going to have the greater rotational energy, so that means that the sphere is going to be less than. And the last part is the horizontal distance the sphere travels, greater than, less than, or equal to. And for this one it's going to be greater than, because since the inertia of the sphere is less, that means that more energy is spent on it translating and less on it rotating, and therefore it is able to translate a greater distance along the horizontal field. And so there you go. Hopefully that helped. If you have any questions, make sure to leave them in the comments below. that's all I have for you guys today. Make sure to tune in again for more kinetic tutoring tutorials.